Okay, so we start lecture today. This will be training for you to understand about the computer. Okay, in this program, you get two major course: electronic and a digital. They're completely different. Okay, you don't have to understand electronic. You still can be understand in the digital system. Quite different. Okay, and we go from the basic. So hopefully you can understand. The first thing is we're talking about a number, system, and cost. Okay, so basically you get, let's see, decimal number system. So everyone already know decimal number system will be 0 up to 10. Hello?
Thầy, cái website vô có quyền lợi tốt rồi,
I don't know.
tôi bấm hoài nó không vô.
Oh, I cannot help. Okay.
Thầy,
First thing is a decimal number system. They're going from 0 to number 9. So they get a 10 digits, so that's why base 10. Okay? That's a very simple thing. Nothing we can talking about the decimal number system. And the second number system, that will be a binary number system. Okay? And they will be two digits in binary only. Either they equal 0 or they equal 1 and no more. That's why they get only two numbers. So the base will be base 2. Okay? And then the octal number system, they get 8 digits. So that's why they get base 8. Okay? And that will be number 0, 1, 2, 3, 4, 5, 6, and 7. Okay, and the last one, that means hexadecimal number system. Okay, they get a 16 digit. They get going from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So that's why they call a B 16. Okay, and then you can learn in binary to decimal conversion or decimal to binary conversion. Okay, now we'll see. Right now, we don't care about decimal to binary conversion. Technician, we don't need it. You can read it, okay? And hexadecimal to the decimal conversion, okay? We also don't care on this thing, but you will be really care about binary to high conversion. And we don't care octal, so that's why I'm not talking about octal. Okay? And let's see what else. Okay, now I will be go through that for you. Okay, first thing you get a decimal. They get only the number from 0 to 9. Okay? So basically, if you get number 3, 4, 5, and they put 10 here, that means you know number 345 will be in the decimal. However, normally later on, you don't have to put a number 10. Okay? When you get a 3, 4, 5, and now I can write it down different way. I take 3 times 10. What power? 2, right? And you adding number 4 times 10, 1. And you adding 5 times 10, of 0. Okay? So you can say 3 times 100. And you adding 4 times 10. Then you adding 5 times 1. And you're still coming up 345.
Mr. Pham, that should be four in the middle. It should be 4 times 10.
4 times 10. Thank you. Okay, now why we times 10? Who knows why we times 10?
The base 10.
That exactly. That will be the base 10. So that's why we times 10. Okay? So basically, 100, 3 times 100 just telling the weight of the decimal. Okay? So everyone already know this one. And then we can go number 2, that's a key point, binary. And they say base 2. Okay, they can get only either 0 or 1. They get only 2 digits. So that's why the base 2. Okay? And now you can see this is the number. This is a binary. You don't have to put number 2. The reason is, that's just a 101001. So that will be telling you they will be in binary. So basically, binary, that is the language of the computer. The computer understands 1 or 0, but a human cannot understand. So that's why we need to converting the binary into the decimal. The way we do, first thing you take number 1, you times joule. What power? What the power?
3 power.
3. That means you right here. Okay? And you count how many bits left? 1, 2, 3. Power 3. Adding to the next one, 0 anyway, they be 0, we don't care. 0, you don't care. And now you adding this, the last one here. 1 times 2. What power?
0.
What is the power?
Then 0.
0. Okay? And now you can say 2 power 3 equal what? That means 3 times 3 times 3. Right? That is 2 power 3. 3 times 3 times 3. That's number 9. 9 times 1, that means you get number 9. And you adding, let's see, 8, number 8, right? 2 from 3. Sorry. I get it wrong right here.
Yeah. 2
Ah, I get. Okay. 2 power 3. 2 times 2 times 2. That means 2 power 3 equal. Right? So that will be equal number 8. Adding to 1 to the power of 2 power 0 equal what?
1,
2 power of 0 equal
1,
any number with a power of 0 must be equal to 1.
and 1 times 1 is 1.
Okay, 1 times 1 will be 1. So 9. So the number computer know 0, 1, 0, 0, 1. And you know that equivalent to number 9. That's very important to you. Okay? You must know how to do it. Okay? Now you're doing for this one. I get the number here. You're doing a calculation telling me what decimal you get. See what you get.
26,
Okay, one people get number 26. Did you guys get the same or no?
16 plus 8 plus 2, right?
I don't care. Just tell me what you get number.
Yes, that's correct. 26.
Okay. Make sure you're able to get the number 26. Anyone don't get that number, just bring it up. That I said that a news to you guys. Okay, so look like everyone knows, right? How to convert it from binary into the decimal. Now you can see I get 1, 0, 1, 0, 1, 1. 0, 1. Okay, now how many bits on this combination here? How many bits?
8 bits.
8 bits. Okay, in the binary, they call x digit is 1 bit. Okay, so that will be 8 bit. So that's why you can see in your computer. Your computer, how many bits? You can see they can say 64, right? 32. That means how many bits? Okay, and by definition, the leftmost here, they call M at B. That means most significant. Bit. Okay, on the rightmost here, L at B. Lead. Least significant bit. That's just by definition. Okay, they can be 8 bit, they can be 16 bit, they can be any bit. However, on the leftmost will be M at B. On the rightmost have to be L at B. Just the name. Okay? So, can you do it for me? What decimal equivalent here? I want decimal.
173.
What you get?
173.
Okay, he said 173. Okay, anyone get the same? So basically you're using 2 power, right? That will be 2 power of 1, 2, 3, 4, 5, 6, 7. Adding to this one, 2 power 1, 2, 3, 4, 5. Adding to this one, 4. And this one, 3. And this one, 0. 2 power of 7 is 128. That means 2 times 2 times 2 times 2, 7 times 128. 2 power of 5 means 2 times 2 times 2 times 2 times 2, 5 times 32. 2 power of 3 means 8. 2 power of 2 means number 4. 2 power of 0 is 1. You're adding up. If you get the right one, I believe 173.
Hey, Mr. Pham, I think you got them, you kind of, I know because you're writing on the board, but I think they kind of mislined up. Like the first one is 2 to the 0, and then where you have the 0 at is 2 to the 1, where the 1 is 2 to the 2, and the other one 2 to the 3, and the 0, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7.
Okay? The
It's
first
just,
one,
it's just the way you're writing. It's no big deal.
okay? The first one 2 power 7, right? The
Well, I
next one,
started out on the right side
yeah,
where it's 2 to the 0.
I don't care 0.
Yeah, right.
I just care number 1.
Correct, correct.
Okay? This I said this is very, very basic. Okay? When I given you the binary, you ever want to convert it to the decimal. Okay, now, how do you want to tell the computer something for you? In order to tell the computer do things for you, what can you do?
Program.
Ha! You need to write program. Okay? Like when you turn on the computer display the window. Microsoft have to write the software to tell the computer do window for you. That means whatever you want to do, you have to write the program. Okay? And basically the program different type. One will be high level language. Number two will be low. Okay? Two different type. One will be called high level languages. Another one will be low level. Now, high level, that means using English. Okay? Like you can write a program using the English. That means you're using alphabet to write the program. Everyone they read, they can recognize. Okay? That's what they call a high level. The low level, then you can use in binary. Okay? That means when they want to write the program in the low level, they have to use in 0, 1, 1, 1, 0. They want the computer language. So they talk directly to the computer. Okay? That's what we use in the assembly. And this one like Fortran, Pascal, C, or C, Lot, Lot. C or C plus plus, that means you wrote a program by English. You reading, you understand. However, assembler they writing the program by the computer language, by binary. They want to talk directly to the computer. So that will be telling you they write a program with a low level, then the execution will be faster. Okay? And if you're using the high level, the computer execution will be a little lower. Why lower? The thing is you're using the English for the high level. When they go to the computer, they need to the translator into the binary so the
Mis-
computer can understand. That take a
Mr. Pham,
yeah.
is that basically the same thing that happens when we compile our C++ programs?
Yet when you compile C++ program, they converting to the binary.
Right, exactly. Thank you.
Okay, so that's why it take a little longer time for the low level. Low level, they write the program by the binary, so they talk directly to the computer. Exactly the same thing you can see. I can talk to the American. Take a time for my brain to converting from English into my language so I can understand. However, a two American talk together, they can understand right away. Okay? So that is basically you have to understand that a different two uh, language, two level. Okay? And now we're talking about hexadecimal. Hexadecimal. Okay. Hex will be going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. That means the base number 16. I think they get 16 digits. And now we want to make sure you know how to conversing. Conversion from binary to the hex. And also from the hex to the binary. Now, convert. Okay. Binary to hex. If you get the number here, 1, 0, 1, 1, 0, 1, 0, 1, and 1, 0, 0. Let's see. Okay? So if you get too much, 1, 0, 0, 1, everything, and we want to convert it to the hexadecimal, the way we will do it from the right to the left, divide 4 bits. This the first one. 1, 2, 3, 4. That's the second one. Okay? And now you change for X1. That means you try to see 1011. What the number? If you go a little down, you can see you get a table. Okay? The table will be telling you. Now who know 1011? What in the heck?
Hey, Mr. Pham, is that B59?
Yeah, now, if you see number 9 here, binary will be 1, 0, 0, 1. Number A here, 1, 0, 1, 0. And B and C and D. Okay? They get a table. You're looking into the table, you can get it easy. So now 1011 that equivalent to B.
B.
Then you get a 0101. What number?
5. We use it all the time.
Yeah. If you don't know, you can using 1 times 2 power of 2 plus 1 times 2 power of 0. So you get number 5. And this one,
9.
number 9. So they equivalent to B 5 9. In height, that means B 16. Any question for this conversion? No question?
Yeah, Marcelo here. One question, Mr. Pham. What was the criterion to where to place the arrow that you you place just under the 1 and then under the 0?
What that mean? First thing you get 1011 here. What number here I give it to you? Okay? That binary.
Yep.
I want you tell me what equivalent in the hexadecimal.
Yep.
I already telling you. From the right to the left, divide by a group 4 bit. Okay? So this is the first one. And you count 1, 2, 3, 4. Second group. And the last group.
Okay, got it. Thank you.
Then you change from each group. That's a very simple. I given you a 1011. They will be number 11. 11, that means B right here. You can see that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A means 10. B means 11. C is 12. D 13. E 14. F will be 15. When you get the table, then you know how to do it. You can follow it. Very easy to get through it.
Got it. Thank you.
Yeah, now converting hex to binary. Okay, you want to converting from hexadecimal to the binary. They must be 4 bit for each hex number. They must be 4 bit. Okay, the thing is that already covered in the handout. Okay, I just try to explain to you, make sure you understand. So now the first one, you converting number 3. Number 3 in the binary,
0011.
they will be equal 0, 0, 1, 1. That's number 3. And then you go to the number 7.
0111.
Good. 0, 1, 1, 1. And now to number 8.
Get it, Catherine?
Hi, Joseph.
All right.
A means number 10.
1010.
Good. 1, 0, 1, 0.
Good, Kumi.
Yeah, coon me.
Hi, Kumi.
1, 0. So that is how to converting from the hash to the binary. Okay, so we already know hash to binary. Why we want that? You understand it when they write a program using the low level. That means they have to using 1, 0, 0, 1, 1, 1. Too many 1, too many 0. No way. They can do it. So that in the keyboard, they already converting number 3 into 0, 0, 1, 1. So they can using the high decimal to writing the program in the low level. Instead, they have to using binary. Keyboard will convert it. You type number 7 in the software, they will be telling you that equivalent to 0, 1, 1, 1. Okay? And now, for the technician, okay, for your work, why you need to know?
Is hexadecimal like hardware addresses?
You mean what? Okay, what's the question?
Oh, is hexadecimal used for like hardware addresses?
No, that they can just the way. Instead, they want binary to the computer. But you cannot type 1, 1, 0, 1, 0, whatever. No.
Yeah.
You typing by hex number. Then the computer understand. Like you type letter A. Computer understand it. That is 1010. Okay?
It's like writing in shorthand.
Right. They get a device inside the keyboard. Okay, inside the computer. When you go into the program, you tell, okay, this is a C++. Then, when you type number 3, computer understand 0, 0, 1, 1. Conversion. They do it. Otherwise, no way you can type in 1 or 0, 1, 1, 0, 1 in the program. No, computer cannot understand. Now, for the technician, I get this number. 1, 4, and 5. Okay? So what your work, what your job will be doing in the company? You testing, you following the engineering instruction. telling you how to apply, okay, how to measure the output. So if they say, I want output will be 145, then you cannot do anything. The thing is, if you want to verify, you have to know what bit is a 0 or 1. For example, yeah, I convert to the binary. 1 here will be 0, 0, 0, 1. 4 will be 0, 1, 0, 0. 5 will be, you see that? You must know which bit will be high or which bit will be low. So if you want to take on this bit here, you want it to be high. Okay? If it's high, that means it's good. If it's not, that means some wrong. Okay? You have to get the each binary bit display in order to using the meter to check. That we'll be talking later. Okay? So some very important. That's why I just bring it up and make sure you understand how to converting from hex to the binary. Okay? And also how to converting from binary to the hex. Okay? Okay, let's see. What next? BCD code. That's what they call a binary code decimal. Stand for BCD. When a number, letter, or word are represented by a special group of symbol, this is called encoding. If each digit of the decimal number is represented by its binary equivalent, this produces a code we call a BCD, binary code decimal. 4 bits is required to code 8 digits. They given you example. You get 748741110. Okay, and they want it to be BCD. Now, 87410. They want this number into the BCD. It is 7410. If you want the converting to the BCD, okay, the way will be 8 digits in the BCD must be 4 bits. So the first thing you convert this number here. 4 bits will be number 8 will be 1, 0, 0, 0. That's number 8. They must be 4 bits. Number 7. That's the first one you get number 1,
0, 1, 1, 1.
0, 0.
Now, number 7 is 0, 1, 1, 1.
The next number 7 will be 0, 1, 1, 1. Next number 4.
0100.
And the next number 1.
0001.
And the last one.
Four zeros.
Okay? So if in here they get it wrong, you have to correct that. The thing is they letter B, C, D, they override on that pattern. So the correction will be that one here. Okay, one more. Can you tell me 9, 3, 5 to B, C, D?
1001.
Number 9, 1,
0,
1.
1.
Number 3,
0011.
number 5,
0101.
later when you get a table, you're looking into the table, you can get it done quick. However, make sure they must be 4 bit. So if you want to converting binary to the BCD, they require 4 bit. That means from the right to the left get 4 bit, 4 bit, and 4 bit. Then converting for each one. 0100 will be number 4. 1001 will be number 9. 0011
3.
3. 4, 4, 9, 3. That's more easier than electronic, right?
Yes, sir.
Yeah, that is very good to know. Now, try this one. Who can get the answer for this one? That I want BCD.
C9F.
You say C, 9, F. Is it a right or wrong?
Right.
Ha! Who is it?
Kunmi has all the answers tonight.
B.
Her and Catherine.
Okay, now I understand. BCD means binary code decimal. What that mean? That means the binary working like the decimal. Okay? And you understand that the decimal only going from 0 to 9. Okay? So that will be invalid.
Oh.
The thing is you don't have a number F in decimal.
Oh, that was a trick question.
Ah,
Got us.
you get only 0 to 9, but they in binary. They require 4 bit. That will be also same thing.
Because that's the same as 12.
Right. We don't have a number 12 in the decimal. 0 to 9 only. This time I given you guys more tricks.
Hey, Mr. Pham, so when you get something like that, it should be just like you have it up there, correct? In other words, you could use you could put down 1100 and 1001 and all ones, but then you would have to X out the first one and the last one because they're greater than 9.
Okay.
Is that correct?
That's only thing I want you understand it. That's it. Nothing.
Okay.
Okay? The thing is the way, the teaching a different way, right?
All right.
This time I spend a lot of time to research, to prepare. You can see the lecture this time is completely different in the past.
Yep.
I want you really understand to be a technician. If you not understand, you stay here forever.
Still the 21st century, right?
Okay, let's see what else. BCD, access tree code. Okay, we don't care for now. Okay, we'll be talking about later. Alpha numeric code ASCII. Okay. Uh-oh. How come low battery?
Uh-oh.
Oh. How come I put it jack all the time? And now the low only 10%.
Cigarette break.
That I check it out. Why? Oh. What hell here? I see the problem here. Okay, so you guys just take a few minutes break, okay? Now we'll be okay.
I'm going for donuts. Somebody needs some?
I never know they can be happen this way. Just a few minutes break. So this time you can see we don't have a much left, okay? We get a lab how to do, know how to do, how to troubleshooting. Okay?
Hey, Mr. Pham, was that something on your side that said the battery was low?
Yeah. On my iPad, it is losing connection.
Yeah, I think you had like 10% left.
Yeah. I did I didn't pay attention. I thought they already connect all the time. But just take about few minutes so we can start keep going.
Got to charge it up.
Yeah. Make sure this handout cover for at least 2 or 3 meetings. You can see very long. And you will be get the homework to do. Everyone have to do your homework. You missing you might don't care. But you not turn in your homework, you can stay with me.
Forever.
Yeah.
If we stay, Mr. Pham, we have to have Paul look.
You have that Kumi and Catherine stay too.
Sure. I'm in.
Kumi
I'm
very good.
in.
Kumi
Yeah.
very good. But next time try to get the right answer.
That's why we stay forever.
Yep. Oh,
Yeah, but it's a fun class though.
The thing is, after today meeting, next time will be much better. The thing is you get a chance to read first. Make sure you must be download this file.
yes. Let's see.
You know the thing I can give you a little more clear. Because in the past, in the university, I get too much problem. I don't understand. Okay, Alpha American Standard Code for information interchange. Okay, now this will be going back with those things later. Now we need to do a try to telling you here. Okay, so you understand a binary. Either they can be 0 or 1. However, when you're working on the circuitry, you want to measure the binary. You want to measure 0 or you want to measure 1, you never get. Okay? So that's why they said in electronic, they get a define of any voltage. Okay? High will be 5.5 volt and minimum will be 2 volt. So that's why you can see from 2 volt up to 5.5, they say high equivalent binary number 1. Any voltage from 0.8 volt go to 0. That's what they assign to be low or binary 0. Okay? Any voltage between 0.8 and 2 volt, they will be not allowed. So when you're working on the circuitry we measure, you get at a point A, you get 0.4 volt. Then what is it?
Zero.
Low.
Low.
Low. Means 0. Okay? Now, when you measure at a certain point, I gave it to you. You get point A. you get 0.4 volt. Then telling you A equal what?
Zero.
A
Zero.
equal 0. That means you measure the voltage, and that voltage just telling you
Logic zero.
what logic you get.
Logic zero.
Okay, so that's why you get A equal 0. Now, if you measure at a point B, you get 3 volt. So what B equal?
Logic one.
Logic 1. If you're looking into the table here, you can see. Now, if you look measure at point C, you get 5 volt. Then what you get for C?
1. 1.
What C equal?
1.
Good. 1. By looking into the display here. Okay? Now, you can see, after you get the logic, do not do anything with the voltage. Who cares? If I say, I want B, adding to C, what you think you get?
1.
1.
Okay. They can be 1, they can be 0. However, I bring it up to make sure you cannot say 3 volt, adding 5 volt, and you get 8 volt, right?
Right.
The thing is basically definition here, you don't have a 8 volt, maximum is 5.5 volt. So never try to adding this thing. You have to say 1 adding to 1. They can be equal 0, they can be equal to 1, doesn't matter. But you get only 2 numbers, either 1 or 0. Okay?
Hey, Mr. Pham, I got a question for you.
Yeah.
I pretty much, well, we've encountered this in the past. A lot of times, okay, for instance, like 2.0 volts is a logic 1, according to your table here. But
Right.
sometimes when you measure on the low end of a logic 1 is from 2 to 5.5. And usually if you get up around 5.5, that's a good one. But on the lower side, if you get 2.0, that's a 1, but sometimes the circuit don't work as well. Are you understanding what I'm saying?
Yeah. But normally, logic 1 standard 5 volt. Okay?
Well, I remember when we were talking
Okay,
about the buffers,
yeah.
the buffer.
Not yet. When we go into more detail, you can see output, they want the output minimum will be 2.4 volt. That means when you measure the output only 2 volt, that they not working right.
Can you adjust the current and still have 2 volts?
Yeah, that whatever happened. But at the output, they want 2.4 volt minimum. Input, they can be 2 volt.
So if you get the 2 volts out, even though it's a logic 1, it's the circuit.
That's not the logic 1. What I'm saying, you measure in or out.
Right.
Both they can be 2 volt for high, for 1. Output, they want it to be 2.4 volt.
Okay.
Minimum.
So the output is only high when it's 2.4 or more.
And also depending on, well, this is what they call TTL logic.
Transistor to transistor.
That stands for transistor logic. Okay. However, later on you can get another different type IC. They can say CMOS built by the JFET. Then they want the out in the high will be
Nos tardamos,
3.5 volt
ya
up.
son hasta las 2, pero hay mucha gente.
Okay.
Pero se trajo un buen 80 de 2 bolsas de perro.
Mute.
Yeah. The thing is, I supposed to mute everyone. However, I don't care. The thing I did, like in the class, you can talk anytime you want it. But I don't want outside interference into the program. You have to be careful, okay?
Mr. Pham,
Yeah.
in the situation that you were just talking about 2 volts and having it be a high, a 1, you can introduce more current into your circuit and still keep 2 volts, right? But still make the circuit work.
Yeah.
Right. So even if you had 2 volts and your current was low, you could still receive an error. Like say in analog to digital, because you have to have the current flow.
No, that's a different story.
Right, but still, you can still have high and your circuit work. You can still have 2 volts and have your circuit work at 1. The only problem is your current is what's
I
determining.
understand what you're saying depending
Right.
on the current.
Right.
However, what I'm saying is, you never have to deal with the power. Okay? Also at work, the same thing. At working, okay? Now I can tell you what happened when you're working as a technician. The board already built. Engineer already write a program to test that circuit board. When they say pass, that means good. Okay? And they can send it into the customer, they can use it. After for a while, customer say, okay, this board is not working. They send it back to the company. And now this is your job. They given to you to fix it. That means you just troubleshooting to find out what's wrong. But nothing can be wrong with the power. Okay? So you cannot change the current anyway. Now, the next one, given you this thing. This is the clock signal. That means you can get like square wave. Only thing the difference between the clock and the square wave. The square wave they get positive voltage and the negative voltage. However, the clock they cannot get negative. 0 will be 0 volt. 1 will be 4, 5 volt. So you can say 0 here, high here, and they keep running forever. So from here to here, that's a one period. Okay? And you can see another they using a bit sequence. That means this logic 1 here, then go 0, then go 1, then go 0. And this still be 0 and 1, 1. Okay? That's just a sequence. But only 0 and 5 volt. Now, another thing, when you get only single pulses, that means you get 0, then go high, then go low. That's what they call a positive going pulse. They going from 0 to 1, then go down to 0 and no more. Okay, only one. That is a positive going, positive, positive. And another one opposite, normally high, and they going low for a short time, go back high only. Okay, that only one. They go a negative going positive. Okay, and one going up, they go a rising or leading edge. Going down will be falling or trailing edge. That's just a definition. Okay, and now also here they say a portion of periodic digital waveform is so here. The measurement are in milliseconds. They want to know the following. First thing they want the period. You understand period will be going from here to here. Okay? And you can see that the period.
Mr. Pham, are you writing on the screen? If you're writing on the screen, we can't see your writing.
That means period you see it right here. Period.
One complete cycle.
Same thing. Like you learn electronic. Complete cycle.
Mm-hmm.
That means period.
Right.
Okay? And T equal 1 over F, right?
Time, yeah.
RF equal
1 over T.
over T. You guys only did get to take one. No big deal. Okay? And they want to know which one is a period or frequency or the duty cycle. Duty cycle will be this formula. That means you take TW. That means the part of the high divide by period times 100%. That telling you duty cycle.
Mr. Pham, the TW, what does the TW represent again?
The weight, the time of the weight. T means the time.
So if I mean just to do only one problem, the width in this case would be what, 1?
No, the weight means at the high. They not one. Okay, I go this one for you. Okay. Now, you can say I get this signal. Okay. I want the duty cycle. D. Okay. That means equal T W, right?
Right.
Divide by T.
Mm-hmm. Times 100.
%. Now, from here to here, 100%. Okay? From here, how many percent?
50% is half.
Percent. And that will be 50. Okay? So basically, this will be a 50% duty cycle. Okay? That means they get a half and a half, 50%. Now, if you get the signal like this thing here, and they given to you, that is 20, and that will be 80. right? 1 T.
Okay. Okay, yeah.
So the duty cycle will be D equal 20 divided to 80. Now 20, um, let's see, divide to 100. How many percent?
20%.
20.
20.
20 divide 100, you get.
And Mr. Pham, how come you crossed out the 80 and put 100 in? I know it's time 100.
80 mean from here to here to make complete 100%. You see what I'm saying? They go high for 20. They going low for 80.
You're only using percentage, correct?
Yeah, you time 100.
No transition time, no.
No, nothing. They just want to know, I want the signal with 50% duty cycle. Like
What?
this one.
One cycle being 100%, right?
One cycle will be 100 from here to here. And now you get, if they given you this at 20, then this have to be 80. Right?
Right.
Okay? So if you want to calculate the duty cycle, you take 20 divide to 100 times 100%.
And the only real work that's being done is 20%.
Right. For example, this one, they get a problem when they interview. Something very easy, but they don't understand and they get a problem. Okay, they say, I want, okay, 40% duty cycle. Signal. Now you have to draw the signal with 40%. So if you understand, you can say you draw that one here, and that one here, and that one here.
Oh, because you're doing 40 and 60.
That, and now you mark it up for them. 40 here, 60 here. That will be 100. So duty cycle will be equal 40 divided 100 times 100%. The thing is, normally in the class, you can see the signal will be this way. How many percent? All the time,
50.
50%.
50-50. And that would be a good analogy for the clock, right? Because usually for the clock, they're half and half.
Right. But sometimes in the digital circuitry, they want to apply the clock with a different duty cycle,
Okay.
not 50-50.
Mhm.
Then you must be understand. If they say, I want the signal with 10% duty cycle, then you can know right away, this is the first one, then this is the next one, and this will be the next one. So you say that will be 10, that will be 90, right?
Mhm.
Then okay, you understand.
Hey, Mr. Pham, I think Lowell was asking about it earlier. So that small number means that whatever you're doing is working 10% of the time, and the other 90% of the time, nothing is happening?
No,
I'm asking.
The one value or the high value, that's considered a work time or duty time. It's when
What is, wait a minute, Lowell, you can answer my question. What is the one for 10, what is that one? And then the one for 90?
They go high only 10 millimicrosecond. Then they go low.
Okay, so it's only, the 10 means it's only working 10% of the time.
No, it not mean 10% of the time, depending on the circuit. You
Okay.
cannot say they work only 10%. No. This is the signal applied to the circuitry. And that circuitry designed that way. They want only high at 10 microsecond, then low for another 90. Nothing to do with something else.
Okay, all
But
right.
Mr. Fan, but technically your circuit's only working when it's high versus when a gate's gonna close or open versus the other thing.
Apply to too many different things. We cannot talk about the gate.
But current is, our voltage is mainly flowing at high.
We don't care about the current. We care about when you measure on oscilloscope, you're supposed to see this signal. That's what they want, 10%, 90%.
Right, I understand, but the definition of duty cycle, the
That's how many times they high, how many times they low.
right, no, I understand, but the definition of the percentage
That they call percent.
of what duty means. Duty itself.
Now, they remain just telling you they want to get that kind of signal this way. I say duty cycle 50%. Then you have to find out.
But it's only one cycle, correct?
Now, too many cycles or one cycle doesn't matter. But the signal coming out have to be good. Like,
Mr. Pham, sorry, Mr. Pham.
like I want 50%. Then you try to display 50%. That's it. I don't care, after that, how many more. Doesn't matter to me. But if I want to draw 50% duty cycle signal, then you must be this way.
Sorry, in the last your drawing, it is 90% of the cycle. We can call it a cycle up. Cycle up.
How many percent?
The last your drawing is a 90. We can call it is a night cycle up.
That is 90. Let's say we say 90%, right?
Yeah.
Okay.
The last your drawing.
That's okay. No, it's not mine. This is a 90.
He was asking about the one, Mr. Pham, where you had 10% and 90%.
10%.
Yeah.
Now, 10%, that will be this way.
And then 90.
Right.
So he wanted you to explain that.
That is a 90.
Yeah. We can call it 90. It is cycle up because sometimes they want me to measure the cycle up on the oscilloscope. Yeah.
Measure what cycle?
Cycle up. They in the procedure is they talk they tell
if
yeah.
you want to measure the cycle.
Cycle up, cycle off.
Cycle up.
Yeah.
I don't understand what that means, cycle up. Depending on circuitry. That means on the circuitry, they want to see high that are not up, they on. And that will be up.
So whatever's happening is working 10% of the time, and then the other 90% is off.
That doesn't matter, depend. If they want to measure the cycle, if they say cycle up, you have to go in more detail, okay? However, for duty cycle, that is how.
But it is only one cycle, correct? Only one cycle?
They can be too many the same. We don't care.
Well, that's why I was wanting clarification. So if we're measuring only one cycle, you can have 3 peaks.
Yeah,
in
it
one,
is the same.
in one cycle, right?
Yeah, it is the same.
So how is the percentage divided in one cycle if you have 3 peaks?
No, the cycle is just a repeat sequentially, a repeat, and we need to measure the cycle.
Exactly, but that's not one cycle, that's 3 cycles. So within one cycle, if you have 3
That's
peaks.
okay. Only
Right.
one. You don't care about the other. If they given you a signal with different cycle and they want measure each one, that's a different story.
Well, that's what I'm saying. If one cycle has 3 peaks, how do you define 3 peaks in one cycle as far as duty cycle?
Oh, how come they say CPs? You can get that one here. And you can get same thing. Man, how come?
You need a ruler so you can draw straight lines, Mr. Pham.
Yeah. If you hold it. See that?
Yeah.
Now, I want that. Let's see. What I want. Okay. Okay, how many percent for that one? If I given you 90 here, that will be 10.
10 and then 90, then 10.
90%.
10.
Okay, so the duty cycle will be
90%.
right? Divide 100.
Hey, Mr. Pham, I have a question.
Yeah.
What could be the advantage of have a duty cycle of, for instance, 10% in comparison to the classic 50% that you mentioned a few minutes ago?
You mean 50%?
Yeah. What is the advantage of have a short duty cycle? Let's say 10% versus 50%.
No, that's they talking about duty cycle. The signal here will be how they look like.
Yeah, but is there a benefit to use a
Who cares? No, that's not any benefit.
But if you are using a system that is operated by a battery,
The design. Engineer, they design the circuit. And you don't know where that doing.
okay, you're right.
Right?
Yeah.
You don't understand, what happened for that. Who cares? They want to measure 50% duty cycle output. That's it.
Hey, Mr. Pham, so basically what you're saying is the duty cycle is 100%. And half of it or part of it can be 10, the other part can be 90, part of it can be 60.
It can be 80.
Right. But
Then
long as
it can be
the
high
thing is,
30, low 70. They can be high 50, low 50. They can
Right,
be any.
right. Got you.
But one thing, you don't care about benefit. What happened? No, that depends on engineer design.
Okay. And we're not engineers, we're technicians.
Is that 2 cycles?
Oh, no.
We don't care the 2 or 3 cycle.
I want to see 3 peaks in 1 cycle and then define the percentage.
You have to do that on Falstad.
Okay.
No, we'll have to pick on Kumi this time.
Now, in the binary, 2 ways to sending data in binary. One, they need only 1 wire, and they get too many bits. 1, 2, 3, 4, 5, keep going. Okay, that's what they got talking about serial data. Serial data means the bit go one follow the other. You need only 1 wire. Do you know in your home which one they using the serial?
Are you talking about like telephones and TVs?
Exactly. Telephone, they only need a 1 wire. Okay? The data transmit a million bits. Okay, no big deal. However, if you're looking on the next one, this is a parallel data. Parallel data require 1 bit for 1 wire. So now you can see 1, 2, 3, 4, 5, 6, 7, 8 bits. You want to transmit 8 bits, you need 8 wire. If in your house, the phone they using the parallel data, you don't have a room to put a wire. So that's why they must be serial. Your computer, when they say 64 bit, that means inside they must get 64 wires. The reason is, inside the computer cannot working with the serial data. They must working with the parallel data. Okay? So when they say computer 64 bit, that means inside a thread they have to be 64 wires for a thread. Or 32, means 32 wires. Okay? So now you can understand one thing. When you want to transmit data from one place to the other, they have to use in serial. However, when they go to the computer, that serial must be converting into the parallel. Otherwise, computer cannot do it. They're talking about parallel, serial, and parallel data. Any question?
So then serial is like 1 wire, 1 bit, 1 wire, 1 bit, and then parallel is just 1 separate wire.
Now, serial means need only 1 wire.
Oh, serial 1 wire.
And they transmitted too many bits.
Okay.
Okay?
So 1 wire.
Parallel, 1 bit need 1 wire. That's how you in here. Okay? They already show you here.
And that's why we have the shift register ICs that turn the serial data into parallel data?
Exactly. That one in any computer, they must get that IC. So when the serial coming, they converting to parallel for computer to work. And when the computer done send it out, they must convert it back to serial. The cell phone, same thing. When you're talking to your cell phone, so basically that will be a sound wave converting to electrical wave. That means the analog signal. Then they have to go into the device they call a A to D converter. That means they have to converting that analog to the binary so the computer can do. And after the computer done, they send it out. They must be go to the device called a D to A converter. Go back to your voice. Then they can set it up. Everything that you will be learned in this program. Now you can see the number will given to you here. Okay? 0 decimal, 1, 2, 3, 0, and so on. Okay? Quickly, and we can quit. Okay, this is just to bring it up to you one thing. You get the IC to call encoder. In your keyboard, okay? There's a keyboard in here. You type number 9. Okay? And basically computer cannot understand number 9. So that's why they need this IC to converting to the binary number 9. That means they converting to 1, 1, 1, 0.
0, 1.
So the computer can do it. Computer cannot do anything with decimal. Okay? So that's how they work. And now another one, decoder. That means you get a binary like number 8. Number 8 means 1, 0, 0, 0. Computer can understand number 8, but you cannot. So that's why they need the decoder to connect to the LED. So they can display number 8 equivalent to the input here. Okay? That's it. And next time, we'll start with the binary decimal conversion. And everything here, too many. Okay? Try to go through it. Next time, we can do better. So, any question?
Thank you, Mr. Pham.
Thank you, Mr. Pham. Enjoy your
Thank
evening.
you.
Thank you.
You're welcome.
Thank you. See you tomorrow.
Thank you.
Thank you, Mr. Fan.
Okay, so this lecture will be paused tomorrow on the Zoom, on the
Video?
on the Facebook.
Bye.
Okay, you can,
Tomorrow we will this digital tomorrow.
yeah. Okay, now I show you one thing. I stop share this one first. Okay, I can share with you quickly here. Okay, now if you're looking here, okay, and you go down here, they say lecture video. Okay, click on that, and they go to lecture here by my name. Okay, like yesterday, diode, you click on here, and they will be go to that.
Go to Sam?
Yes.
Hey, Mr. Pham, I tried to download that handout. Nothing.
Okay, so basically, they're telling you on off the lecture in the Zoom will be paused next day. If you still confusing, you can see again. Or if you're missing in the meeting, you can do it. You can,
Thank you very much. Thank you very much.
yeah, we do the best. Okay?
So, Mr. Pham, tomorrow is Thursday. On the website, it doesn't say anything about Tech 2 meeting separate.
Tech
So-
2 only one day.
One day.
Wednesday.
Okay.
Okay?
But
Thank
you still come every day.
The thing is you already get to Tech 1. You already get a basic, easy to teach. Okay? So that take a less time.
But everybody comes every day, right, Mr. Pham?
Right.
And tomorrow we will go to the Mr. Thai.
Right. You can go, then you can leave. Doesn't matter to me.
Thank you.
You already know what to do. Who cares? Just do the homework. That's why they online they divide two things. One will be synchronous and asynchronous. That means the time you in the Zoom. Asynchronous means the time you have to do your homework. So that's why we control the homework. Very careful. Okay? Even you already know, but I didn't see your homework upload. Then you have to stay forever. I don't
Okay.
care. You've been
Me and-
here from spring or summer or now, okay?
Me and Chu Lee gonna stay forever.
This time I try to run teaching you very basic thing. You have to know. Okay, good night.
Good night.
Thank you.
Good night, everybody.
Good night.
Bye. Bye.